going to tell you a tale of air quality in three very different cities, Beijing, China, Los Angeles, California, and Atlanta, Georgia. And since I work for NASA, I'll be telling this from the perspective of space. This is a satellite image of northeastern China, and you can see this thick smog enveloping the entire area, and including the city of Beijing, China. And from the ground, the pollution, the smog, is stifling. It's not uncommon to see people wearing these face masks to help protect them from the pollution. So what is smog? Smog is a combination of the words smoke and fog, and it's really just a catch-all for any noxious soup of pollutants. In the case of Beijing, the primary component is particulates coming out of the tailpipes of cars and out of smokestacks. So it occurs whenever you burn fuel such as gasoline and coal. And the problem with these particulates is that when we inhale them, they can go deep into our lungs, and they're toxic, and they can embed themselves into the lining of our lungs. And the smallest of these particles can actually enter our bloodstream. Okay, here's an image of the Forbidden City, one of Beijing's top tourist attractions. And this is on a clear day, and this is on a horribly polluted day. So I would rather be a tourist on the clear day here. Now on the polluted day, the levels of pollutants can be 10 times greater than what's considered hazardous, and 40 times greater than what's considered to be healthy. Okay, now the Chinese government has developed their own air quality index, similar to the one that we have in the US. And they developed, or they created these cartoon characters to convey the daily air quality index to the Chinese people, and they call these the Shanghai Girls. The Shanghai Girls become increasingly distressed as the AQI goes up, as the pollution worsens. Okay. You wouldn't be surprised to hear that this is not an official Shanghai girl. This is called the Beijing girl, and she's created by a concerned Chinese citizen. And this citizen was concerned because these levels are above the highest level of the air quality index. And in these situations, this air quality is considered to be beyond index. So why is China so polluted? Well, in the last several decades, they've undergone an industrial revolution, and this has been fueled by China's cheap and abundant coal. And along with this industrialization, there's been an increase in urbanization as well as the standard of living. So the Chinese people are manufacturing more goods and they're consuming more goods. But more importantly, they are exporting many of these goods, and they're considered to be the world's manufacturing hub. When you burn coal, sulfur dioxide is released, and it's a precursor to acid rain. It's a primary ingredient, and it also is a contributor to these particulates that plague Chinese cities. Here's a representation of satellite data of sulfur dioxide, and you can see it's pretty high over much of China, and it's highest here in this region and that region where there's a high density of power plants. For perspective, here is the United States, and you can see that the pollutant levels are much lower. The Ohio River Valley has the highest concentration of power plants in the US. And it's much lower in the US because it's required by law for these power plants to operate scrubber technology. And these scrubbers literally scrub or remove the SO2, or the sulfur dioxide, from the effluent of the power plant before it's released to the atmosphere. The problem here is this scrubber technology is incredibly expensive to operate. So places like China and India simply can't afford to. But it wasn't so long ago that pollutant levels in the US were very high, and some of the most polluted cities in the world were in the US. And Los Angeles was the poster child for this. And you can see in this image, which is not a satellite image, it's actually a photograph from NASA's Skylab space station in 1973, you can see this thick smog in the Los Angeles basin. The first smog event, major smog event, occurred in 1943 during World War II, And the residents of LA initially thought they were under attack by a foreign power. And this is because the smog was stinging their eyes, burning their throats, and there was an odd bleach-like odor. It smelled like a chemical. And interestingly, they noticed during these smog events that their rubber tires on their cars were cracking. So the residents of LA, they protested to the city government. They said they wanted cleaner air. And this is a protest by the Highland Park Optimist Club. So city officials responded by initially banning the burning of trash, which was a common practice at the time. And they also shuttered a few factories that they thought were particularly polluting. But unfortunately, the smog persisted. Scientists finally figured out that the primary ingredient in this smog was ozone. And as time went on, these ozone episodes just got worse. Here's an example of 1955 and 1956. All the days listed here had ozone levels above 500 ppb. That's an incredible level. And on this one horrible day, September 13th, it was as high as 900 ppb, and that's 15 times acceptable levels. Just for reference, from personal experience, I actually experienced 350 ppb quite by accident in a lab one time. I was working with a chemical instrument that generated ozone internally to the instrument, and unknown to me, a hose cracked and was allowing this ozone to build up in the lab. And at first my eyes were stinging, my throat was burning, and finally, when I smelled this chemical odor, this bleach-like odor, I knew it was ozone. So I took a quick reading, and it was only 350 ppb. I can't imagine what it would feel like to experience 500 ppb regularly and 900 ppb for hours on end. Okay, so the question still remained, where was this ozone coming from? The scientists figured out it wasn't coming from tailpipes and smokestacks, so it wasn't directly being emitted. Instead, it was being generated in the smog itself. So here, today we know that there are three primary ingredients necessary to form these unhealthy levels of ozone in an urban environment. The first, sunlight, that drives these chemical reactions that provides energy. And of course, LA is in sunny California. The second is a family of compounds called nitrogen oxides, and they are generated whenever coal and gasoline are combusted, so it comes out of tailpipes and smokestacks. The third ingredient are volatile organic compounds, and they primarily come out of the tailpipes of cars and out of some factories. And if you've ever smelled gasoline or paint fumes, you smell VOCs. They're very common. There are literally thousands of these in the urban environment. Here is a representation of satellite data, nitrogen dioxide. It's one of the nitrogen oxides. And you can see all these red splotches on here. They're high levels of nitrogen dioxide. And one of the highest levels is here in Los Angeles. And all of these occur or coincide with America's largest cities, most populated areas. Okay, so scientists have figured out that ozone was a primary ingredient in this smog, and they had a basic understanding of how it was being generated within the smog. So initially, government officials controlled the emissions of volatile organic compounds from cars and from factories, and the ozone levels went down. Then later they tried to control nitrogen oxide emissions from power plants and cars, and the ozone went down even further. As an example, cars were required to have catalytic converters installed on them. And a car today is about 20 times less polluting than a car was in 1960. But the situation was a little harder in the eastern US. They had an ozone problem, but it wasn't so easy to reduce the ozone as it was in California. Here is a satellite image of the Atlanta metro area, and the thing you notice is that there are a lot of trees, and that's the case for many cities in the US, or eastern US. And these trees put out lots of volatile organic compounds naturally. Here is a representation of satellite data of one of these VOCs. On a hot summer day, you see that their concentrations are very high, less so on a warm summer day, and even lower still on a cool summer day. And it's not exactly understood why trees are doing this. It's thought that maybe somehow releasing these VOCs protects them from heat stress, but the exact mechanism just is not known yet. Okay, so in a city, in the eastern cities like Atlanta, the only way that you can really reduce ozone is to reduce nitrogen oxides. It's because there are so many VOCs occurring naturally from these trees that the amount coming out of a tailpipe of a car or a factory is just very small in comparison. Over the last 2 decades, there's been a tremendous decrease in emissions of what EPA calls the 6 common pollutants. They've gone down by almost 60%. And I've talked about 5 of these: sulfur dioxide, nitrogen dioxide, ozone, volatile organic compounds, and particulates. I didn't talk about lead because, as far as I'm aware, we can't measure that from space yet. And even though this may seem pretty impressive or significant that it went down by 60%, it's even more impressive when you take into account that our economy has grown, our population has gone up, the number of cars on the road have gone up, and the amount of energy we're consuming has gone up. And we can see this from space, this major decrease in emissions just in the last decade. Here's a representation of nitrogen dioxide, one of the nitrogen oxides, in 2005 and 2011. And the concentrations went down by 30 to 40% just over that time. Sulfur dioxide, a similar story. Emissions went down by anywhere from like 50 to about 90%. So this has been a real success story. But the job isn't done yet, because about 120 million Americans still live in areas with poor air quality. So we need to keep reducing our emissions. Now, most smog that we're breathing in any particular city is homegrown. It's locally produced or regionally emitted. However, the pollution that we emit today will affect somebody downwind tomorrow. For instance, Europeans grumble that American pollution is blowing in the wind across the Atlantic and degrading their air quality. And people in California complain that Asian pollution is blowing across the Pacific and impacting them. So air quality is not just a local or regional problem, it's actually a global problem now these days. So we need satellites to continue to monitor our air quality from space. There's a fleet of satellites, Earth-observing satellites, that are orbiting the planet right now, and they observe everything from ice sheets to oceans to forests and so on, and including our air quality. And I presented data from some of those satellites, primarily the Aura satellite mission. And NASA will continue to design and build bigger and better satellites and monitor our Earth and our air quality into the future. Thank you.